Hello there, everybody. Today we're going to be going over scientific notation. This is the fourth video in a 5-part series going over properties of exponents. The first video was over multiplication properties, the second division properties, and the third special properties. This is the fourth video, and the fifth will be over rational exponents. So if you want to view any of those other topics, you can go find the corresponding video on our channel. But if you're here for scientific notation, then you're in the right place. So by the end of this video, you should be able to pretty easily convert between your standard notation, also known as regular notation, and scientific notation. So first things first, we need to establish what exactly is scientific notation. Well, the simplest way that I can phrase it is that scientific notation is what allows you to write very large numbers and very small numbers in a much more simple and concise way. So that just means that you have numbers with a lot of zeros, like 10 million or 0.000006, right? Those numbers have a lot of zeros. And rather than write out all those zeros, you can instead use scientific notation to make it shorter and easier to understand and, just easier to read really quickly. So this is the building blocks of scientific notation, the very, very basics. It's the powers of 10. Because the powers of 10 tell you how many zeros you need to put in your number to properly write it out. So for the powers of 10, every time you divide by 10, your exponent will decrease by 1 and your decimal point will move one place to the left. And every time you multiply by 10, your exponent will increase by 1 and your decimal point will move one place to the right. Now what that means is that essentially, the bigger your exponent is, the more zeros you're going to need to have. And the smaller your exponent is, the more zeros you are going to have just on the other side. So bigger exponent, more zeros will be on the right side. And smaller exponent, the more zeros will be on the left side, to make a smaller value. So we can demonstrate this with some examples. The first example tells you to expand 10 to the power of 4. Now, there are multiple ways that you can do this, but the way that I think more people prefer, and the way that's listed over here, is to start with 1. And that might seem strange because, our value here is 10, so why are we starting with 1? That is because 10 has an exponent of positive 1, but 1 has an exponent of 0. Right now, what we're specifically working on is just this base of 10. So in this case, if you're doing, for example, a negative exponent, it might be a little bit weird to start with a positive 1, which is why people recommend that you instead start with that base of 1 with a power of 0. So in this case, we're going to be doing the base of 1, power of 0, but if you prefer to do it with the 10 to the power of 1, feel free. Just make sure that you keep in mind that that's a positive 1 exponent, not a 0 exponent. So in this case, we have 10 to the power of positive 4. It is a positive exponent, so we're going to move the decimal spot to the right, specifically 4 spaces to the right because the value is 4. So let's just put our 1. And there are technically 2 ways that you can do this, so I'll show you both. They're both really quick. Remember, every time you move it 1 space to the right, move your decimal 1 space to the right. So you can just put your decimal by this 1, and then you can count sort of like a little hoops that we're going to make together. So if you just count it, 1, 2, 3, 4. That'll give you your new decimal spot right here. Now each of these little hoops, when they go down, each of them has a 0. The easiest way to remind yourself of this is just because each hoop kind of looks like the bottom of the 0 because it's a curve. And in each one of those, you're going to put a 0. And this will give you your new value. Alternatively, the second way that you can do this, especially when you've established your mastery over this topic better, is you can just add a 0 for each exponent value directly. So what that means is that you go, okay, we have 1, now we need to do positive 4, so that's going to be 4 zeros to the right, and then you can just write out those zeros. It depends on which method you want to use, which one you feel more comfortable with. But either way, after you expand this, you get that 10 to the power of 4 is 10,000. Now, let's work on another example with a negative exponent this time. We have a negative 3. So in this case, we're still going to start with that 1. Just 1 to the power of 0. Okay? And since it's a negative exponent, we are going to be moving to the left. So in order to go from 0 to negative 3, we're going to be needing to go 3 spaces to the left. Got a little tongue tied there, but you get the point. So let's write our 1, and now we need to go 3 spaces to the left. So we put our decimal, and now we count. 1, 2, 3. Put our new decimal point, and each one of these hoops gets its own 0. Now, of course, the faster way that you can do this is you just write the 1, and then you say, okay, we're moving 3 spaces to the left, so we need 2 zeros, because the decimal was already behind the 1. So we only do 2 zeros, because one of it, just putting that 1 behind the decimal instead of adding the 0. But of course, when it's a negative exponent, that does get more confusing, so I would recommend doing this method instead, where you actually count the decimal. But once you expand it, you're left with 10 to the power of negative 3 is 0.001. I just added an extra 0 on there because that's how most people write their decimals. Alright, now moving on to something slightly more complex. Now we're going to be incorporating what most people think of when they think of scientific notation, and that is this format, where you have some number times a power of 10. This is also known as multiplying or dividing powers of 10. In this case, we're only going to be talking about multiplying. So it states you can also move the decimal point to find the product of any number and a power of 10. You start with a number instead of starting with 1. So whereas you would normally start with 1 as your base value, instead you're just going to be starting with whatever value is being multiplied by the power of 10 is. So in this example that they have, this is 125 times 10 to the power of 5. So you start with that 125, and you take that decimal and you go 1, 2, 3, 4, 5, and you move it 5 places, and then you add in those zeros. Here, they have 36.2 times 10 to the power of negative 3. So they take the decimal point that is already between this 6 and this 2, they take it and they go, okay, 1, 2, and 3. And they move it 3 places to the left. So essentially the same concept as before, except for instead of starting with 1, you're starting with the beginning value, or the first value that's listed as being multiplied by that power of 10. Here is an example that we can work through. It says expand 3.1 times 10 to the power of 5. So once again, start with that first value. In this case, the first value is that 3.1. So we put 3.1. Now, in this case, you could argue that when you have just the power of 10 problems, you have to do a little bit more mind hoops, a little bit more mental obstacles, but problems like these, which are most of the scientific notation problems, they're very simple because you just read whatever the value is and you just do whatever it says. This is positive 5, so you just move that decimal place 5 places to the right. Very, very simple. So here we have that 3.1. We already have the decimal. It's right here. And now we can move that 5 places. So go 1, 2, 3, 4, and 5. And then you end off with your new decimal point right here. Now, each of those hoops, you add in a 0. So 0, 0, 0, and 0. So now you can rewrite this as 310,000 as your final answer. And if you're wondering, the reason why there's only 4 zeros afterwards is because we spend one of these like decimal point movements just making this 3.1 into a 31. And then those 4 extra zeros get added on afterwards, which is why it's 310,000 and not 3,100,000. Here's another example that we can do. This one has a negative exponent. It says expand 2.4 times 10 to the power of -4. Once again, very simple. Where's our base? Right here, it's that 2.4. So put that on the 2.4, and then you just take whatever your value in the exponent is. It's right there. And now you just do whatever the value is. So here the value is a -4. So you just move 4 places to the left. So take your decimal and just move it. So 1, 2, 3, 4. And you put it down right there. And each of these hoops, or each of these curves, you fill in a 0 for. And then you know that your answer is 0.00024. Or you could just say 0.00024. It doesn't matter. Once again, I'm only putting that 0 with the decimal point after it there because that's how most people write decimals. Now, we're going to be combining this with a little bit of prior knowledge. We're doing multiplying and dividing numbers in scientific notation format. So it says you can use the exponent properties to multiply and divide numbers in scientific notation, or you can use your calculator. I'm going to be showing you an example of how to do this both using those exponent properties or by using your calculator, because they differ slightly differently. They're slightly different. There you go. Alright, here's a tip I put because I think it is a little bit important. It's a little bit clever trick that could help you. So, on whatever calculator you have, times 10 to the power of whatever your exponent is the same thing as e. So in this case, times 10 to the power of 3 is the same thing as saying E3. If you've ever used the Google calculator, you know that in the bottom left-hand corner, there's a thing that says EXP. And if you type it in, it just puts in a capital E into your equation, and that's because that EXP stands for exponent. But interestingly, it doesn't just mean that you're only doing that 3. This E essentially stands for this times 10. A good way to see this is through Avogadro's number. If you've ever taken chemistry, you probably know that. But Avogadro's number is a value of 6.02 times 10 to the power of 23. And if you've ever tried to use a calculator like the Google calculator, you know that you can also put in 6.02 E23 and you get the same answer. So remember, if you're using a calculator and you see this times 10, if you have an E available, once you know that yes, this is the same E that stands for this times 10 for whatever, and then whatever exponent, you can instead use this E if you don't want to write out the times 10, which can be useful depending on whatever you're doing, because depending on how you format it, it might do the order of operations differently, so it could maybe make it more likely that you got the right answer because of formatting. Alright, now Now that that little segue is done, let's get into our example problem. Simplify 8.8 times 10 to the power of 9 divided by 2.2 times 10 to the power of negative 3. The first way that we're going to be doing is the exponent properties, so just right here with us, without a calculator. Now for this one we're going to be relying on the negative exponent rule. If you remember, it is one of them, because there's two versions, but the one that we're going to be using states that when you have a value with a negative exponent in the denominator, you can turn that into that same value with a positive exponent in the numerator. This is what the properties formula looks like. Well, they don't have the over one, but that's just to make it more obvious that it's going into the numerator. So we can apply this to here. As you can see, this says times 10 to the power of negative 3. We can instead flip that to be times 10 to the power of 3 up here. And the thing is, when we do that, we're actually combining these exponents. So they're going to combine to make times 10, specifically added, to make times 10 to the power of 12. And now we have this 8.8 and this 2.2. These are just normal numbers, so there's no special exponent rules. We're just dividing them like normal. 8.8 divided by 2.2 gives you 4. So if we just do our exponent properties ourselves, we will get an answer of 4 times 10 to the power of 12. Now, our second way is going to be using that calculator. So if you input this entire equation into a calculator, this is the value that you're going to get. It's going to take a little bit to write out, so just give me a moment. Yep, you see all those zeros? All those zeros. Because chances are, your calculator is going to write it with all these zeros. It's not going to write it in the scientific notation format. That's what's most likely going to happen. So now we need to change this value into a scientific notation. So first of all, we need to decide what we want to put as the first value before the times 10. In this case, I think it's most appropriate to use 4, because the other version of what we would use is either 40, which is too big, or 0.4, which I'd say is too small. So we just want to have, our base value of 4. And remember, right here, our exponent, it may be technically silent because it's not always written, but our exponent is right here. So we want to move this all the way to here, to right after this 4. And we'll count however many spaces that is, and we'll put that as our exponent. So let's just start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in order to get to that value of 4, we went 12 spaces. And in a case like this, it may be slightly confusing because it may be like, well, why is it not negative 12 when we've been moving to the left? And that's because we're doing it opposite. Because remember, if we had a negative 12 here, that would give us 0.0000000000004. And that's not what we want. We want one with all of these values after 4, to the right of the 4. So we're going to want a positive 12. And if you're unsure on whether it's supposed to be a negative or a positive exponent, just think, do we want a really big number when it's expanded or a really small number? But either way, no matter which method you use, you should get 4 times 10 to the power of 12 as your final answer. Now, here's a fun little one because it's like a word problem. So let's read it out. Light from the sun travels at about 1.86 times 10 to the power of 5 miles per second. It takes about 500 seconds for the light to reach Earth. Find the approximate distance from the Sun to Earth using the formula distance equals rate times time. So, all the necessary information that we need is here. We have our formula, distance equals rate times time. And now we need to figure out what we're missing and what we need to find. Well, it already tells us what we need to find. It says we need to find the approximate distance. So we need to find out what our rate is and what our time is. When you read through the problem, you find out that your rate is this 1.86 times 10 to the power of 5 because it says miles per second, and miles per second is a rate. And it also says that it takes 500 seconds. That's a unit of time, so that would be our time value. So we can write that out as 1.86 times 10 to the power of 5. Looks a little bit silly. It's okay. Times 10 to the power of 5. And then have that be multiplied by 500. And then we need to figure out what that will give us, because that value is going to be our distance. Now, in my opinion, the easiest way to do this would be to expand out the scientific notation and then multiply what we've expanded out with this 500. Because this 500 is asking us to add on 2 extra zeros to this scientific notation. So if we expand it out, we can see how many zeros we have, and then we can very easily add on those extra zeros. So that's the method that I'm going to be using, or rather, steps. So let's first write out our value. In this case, that's 1.86, and we have our decimal point. Now remember, it's a positive 5, so we need to move 5 spaces to the right. So we count 1, 2, 3, 4, 5. We put down our new decimal point, and we write a 0 for each curve that we have. So now we have our new value, which is 186,000, and we can multiply that by our 500. The way that I'm going to do this is first, I'm going to do the 5, and then at the very end, I'm just going to add those 2 extra zeros. So if you multiply 186 by 5, you're going to get 930. Now we take the 3 zeros from our first number, and we add those on, and then we take the 2 zeros from our second number, and we also add those on. And here we have 93 million, which might seem like a lot, but to be fair, it is the approximate distance in miles from the Sun to the Earth, so that's pretty fair. However, there is one more step that we do need to do, and that is finding the scientific notation of this number. Because think about it, this number has a lot of zeros, doesn't it? It is in the millions. So we need to make the scientific notation for this value for our final answer. So in this case, usually a good tip that they give is that you have only one value that is before the decimal point. So what they mean is, like, for example, this 1.86. The only value that is before this decimal is a 1. So in this case, if you think about it, there's really 3 options that we could have. We could have 0.93 times whatever, 9.3 times whatever, or 93 times whatever. Now, the format that is the most reasonable and that people would want you to use your scientific notation in is this 9.3. And so I'd say just always try to have that one value before the decimal point, or to the left of the decimal point, for whatever is being multiplied by that power of 10. So here, we have our decimal point right here. You know what, let me use a different color. We have our decimal point right here, and we want to get to this 9.3. We want to get in between the 9 and the 3. So let's just count. 1, 2, 3, 4, 5, 6, 7. So we moved 7 spaces. Now remember, even though we moved to the left here, we're not expanding. We're writing the scientific notation. So you want to put a positive 7 as that exponent. Because when we expand it out, we want a really big number, not a really small number. So we write 9.3 times 10 to the power of 7, or 93 million. All right, and that is all that I have for this lesson. So here's a quick summary, quick little recap. Scientific notation increases by an exponent value of 1 when you multiply by 10, and decreases by an exponent value of 1 when you divide by 10. This applies to both powers of 10 and numbers that have been multiplied by those powers of 10. You can use properties of exponents to simplify problems involving multiplication and division of numbers in that scientific notation. You can also use your calculator to simplify these problems, but do make sure that you turn your regular notation or your standard notation into that scientific notation. Alright, that's all I have for you. I do hope this helped. Remember that calculator tip that I said earlier with the times 10 being the same thing as E in some calculators. This is the 4th video in our series. The next one should be on rational exponents. So check out the other videos on our channel, see what else you need help with, and if we have anything available for that. And yeah, that's really all I have to say. I hope everyone here has a lovely week. Thank you for viewing. I hope this was helpful, and have a great day and a great week. Bye!